Designing architecture to not only deal with the sun, but to harness its potential as light, heat, or energy is nothing new. Since the beginning of architecture, our buildings have been designed to interact with this glowing ball of energy above our heads. Architects have always worked with the sun to improve the built environment. I think I can safely say that we've all had thoughts and conversations about how to introduce technical installations such as solar panels in our projects the last few years, right? Hi, I'm Jesper, I'm an architect at Autodesk, and today I'm going to show you the solar energy analysis in Autodesk Forma. The solar energy analysis in Forma helps you analyze how to best harness the sun in your project from day one. Harnessing solar energy has become an important part in driving more sustainable building designs, to help you optimize your site and buildings on it for energy efficiency and to contribute to your project sustainability targets. The analysis will help you identify which facades or roofs on your site have the most exposure to sun radiation and estimate how much power can be produced by solar panels annually. By assessing the potential for solar energy during the initial stages of planning, you can make high-impact design decisions that will improve business and sustainability outcomes for your project. Too often, architects know that solar panels may be a good part of your sustainability strategy for your project, but the measurable effect of introducing solar panels to your project is not readily available from the earliest stages. Knowing if solar panels are a suitable solution for your roofs early on lets you design with this factor in mind. Or, alternatively, knowing that your roofs are better suited differently, for example as green roofs, rooftop terraces, or simply technical installation on regular roofing. Instead of wondering if you should have added solar panels, you can move forward confidently, having disqualified or qualified that option early on. The solar energy analysis considers the angle of incident of sun rays, the shading effect of surrounding buildings, and the climate data of your site's location. And this is important. Instead of analyzing for solar panels in a vacuum, you are here considering your specific location and any surrounding context that may give shade or otherwise impact your solar energy potential. A close to real life simulation where you can change your surroundings to account for a future state that may be different from your current state. For example, what happens if trees grow to twice the size, or your neighboring lot builds 7 floors next to your project? Solar panels can capture some of the solar energy and convert it to electricity. This analysis hides much of the complexity on how solar panel systems work, by making some assumptions around the system type, configuration, and operation. Basically, simple broad strokes first, then detailed. The analysis pulls solar radiation data from the Copernicus database, scaling the direct solar radiation for the hourly sun angle. The model assumes that panels lay flat on the surfaces of your model, as well as scaling the diffuse solar radiation using the Sandia Simple Sky diffuse model. The solar energy analysis in Forma reacts to whatever geometry you have put in your project and immediately tells you the annual solar energy potential as a factor of kilowatt hours over a set area like square meters. This is a starting point to start exploring your options. Would your facades be best suited for heavy thermal insulation, sun walls, or do you see potential for a solar panel system? You can of course opt to only consider roofs or any surface or filter based on a specific inclination. In certain areas, especially closer to the poles, you'll immediately see that facades may be as attractive as roofs for solar energy capture. I believe it was Louis Kahn that said, "The sun never knew how great it was until it hit the side of a building." And here in Norway, we all sit in the sun wall to warm up during the winter. Inversely, closer to the equator, the path of the sun in the sky will show that roofs generally are better surfaces to capture solar energy. The analysis shows you the surfaces with the highest potential for producing solar energy. As with most analysis in Forma, you can further filter on the color legend at the bottom of your screen to filter out areas with less potential for solar energy. Let's now talk about solar panel potential specifically. In the lower part of the right panel, you may adjust the solar panel specific parameters with sliders and immediately see the updated estimates for annual electricity produced. So in this example, the project could potentially produce 1,040,000 kilowatt hours of energy per year, assuming a 16% efficiency on panel and a 60% roof coverage. Now, some quick math. If the average energy consumption in France was about 190 kilowatt hours per square meters per year in 2013, this would be enough to power about 100 apartments fully, given that consumption pattern. And this is on a building with flat roof before any design optimization. At this early stage, an estimation of solar coverage and an estimated solar panel efficiency could get you started on the path towards considering solar panels for your next project. With this tool, us architects can ask more informed questions, highlight challenges, and together with our teams find the most effective way to use solar energy in our project. With numbers attached to concepts, we can confidently decide if this is a viable option for our design immediately, and early enough to make impactful changes to our design should we decide that this is a priority.